everyone, and my special greetings to all my dear students. In today's class, we are going to discuss about the second part of the chapter Biomolecules, that is proteins. In the first part, we discuss about carbohydrates. Under carbohydrates, from the monosaccharides, we discuss in detail about the glucose and fructose, and from the disaccharides, sucrose, maltose and lactose, and from the polysaccharides, cellulose, starch and glycogen. Now, these structures can be written in three different ways. The first one is the open structure, then the cyclic structure and the abort structure. And we discussed about the formation of glycosidic linkage in sucrose, in which it is between the C1 of glucose and C2 of fructose. And then we discussed about the glycosidic linkage formation in maltose, which is made up of 2 units of alpha D-glucose, and there C1, C4 linkage takes place. And in the case of lactose, which is made up of beta D-glucose and beta D-galactose, again the linkage is C1, C4. And in the case of polysaccharides, the first one is starch, which is made up of amylose and amylopectin. And we discuss about the difference between amylose and amylopectin. Then we have the cellulose, which is made up of the beta D-glucose, and their little linkage is being formed. And then we have the glycogen, which is also called as the animal starch, and which acts as the energy storage. Now, coming to the proteins, this word is derived from the Greek word proteos, which means something of prime importance. We know that proteins are very important for growth and maintenance of our body. Therefore, it is derived from the word proteos, which means something of prime importance. Proteos is a Greek word. The proteins are also called as the polymers of alpha amino acids. Now, for that, first we need to understand what do you mean by amino acids. Polymer means many, right? Alpha amino acids, many alpha amino acids joined together, you get proteins. Now, the word amino acid, from this you can see that it contains an amine group as the functional group, and it also contains a COOH, a carboxylic acid group. Amino stands for NH2, acid stands for COOH. So now let me write down the general formula of alpha amino acids. You have a carbon atom, and there is NH2, and then you have COOH. You have one hydrogen and one R. Now R could be any group, therefore it is also called as residue of amino acid. Now alpha stands, or it indicates the position on which NH2 is present. Now in this case, this carbon atom, the immediate carbon atom which is next to the carboxylic carbon atom, is called as the alpha carbon atom. Now if the NH2 group is located onto the carbon which is next to the COOH, then it is called as alpha amino acid. Now, based on the position of NH2, there are different types of amino acids. If NH2 is present on the alpha carbon atom, it is alpha amino acid. If it is present on the beta carbon atom, that is, you will have one more carbon atom over here, and NH2 will be on the second carbon atom, then it is beta amino acids. But in this chapter, we are going to deal only with alpha amino acids, because proteins are made up of alpha amino acids. So therefore, only alpha amino acids are of prime importance to us in this chapter. Now, depending upon the R group, by changing the R, you get different types of alpha amino acids. Now, for that, a complete table is given in your textbook. Now, position of the NH2, depending on that, you have L amino acid, you also have D amino acid. Like in the case of glucose, if the OH is present on the right, it is called as D-glucose. If the OH is present on the left, it is called L-glucose. Similarly, in this case also, if the NH2 is on the right hand side, R COH. If NH2 is on the right, then it is called as D-alpha amino acid. And if the NH2 is on the left hand side, then it is called as L-alpha amino acid. Okay, now depending upon the type of R, you have different types of amino acids. There are 20 amino acids which is there in the textbook. I'm not going to write down all the 20 amino acids. I'm going to write down the few important amino acids which you have to remember. If the R is replaced by hydrogen atom, then it is called as the glycine. And each of the amino acids will have 3-letter symbol. It will also have 1-letter symbol as well. So you need to remember the group which you are going to replace the R. Glycine is amino acid in which R is replaced by the hydrogen atom, and the 3-letter symbols will be the first 3 letters. So for glycine it is GLY, and the first letter will be, the 1 letter will be the first letter with which the word begins. So in this case it is G as the 1-letter symbol for glycine. And if the R is replaced by CH3, then it is called as alanine. Again, the first 3 letter symbol will be ALA, and the 1 letter will be A. Now the next amino acid will have R as the CH2 4 times, and then you have an NH2 group. Now if this group is present instead of R, then it is called as lysine. And the 3-letter symbol will be LYS, and the 1-letter symbol will be K. If L is already used for some other amino acid, then you are not supposed to repeat the same letter for different amino acids. Therefore, a different letter is used for 1-letter symbol. So in the case of lysine, it is denoted by the letter K. Now if R is replaced by CH2 2 times, and then you have COOH, now this is called as glutamic acid. Instead of R, you have this group, and the 3-letter symbol will be GLU. And the 1-letter symbol is K. Again, if G is already used, then a different letter is used. So for glutamic acid, it is denoted by letter E. Okay, next one is classification of amino acids. Amino acids can be classified in 2 different ways. The first one is based on its acidic and basic character. Now on this basis, amino acids can be classified into acidic amino acids, neutral amino acids, and then you have basic amino acids. Now this depends upon the number of COOH and NH2 group present in an amino acid. If the COOH group present is more compared to NH2, then it is said to be acidic in character. If the number of COOH and NH2 are equal, then it is said to be neutral amino acids. If the number of NH2 group is more compared to the number of COOH, then it is said to be basic in character. So first let me write it down. If the number of COOH group is more compared to NH2, then it is said to be acidic. If the number of COOH, the carboxyl group, is equal to the amine group, then it is said to be neutral. If the number of COOH group is lesser compared to NH2, that is NH2 is more compared to COOH, then it is said to be basic in character. Now let me give you an example for all this. For acidic, you have glutamic acid. Now glutamic acid is the amino acid in which R is replaced by CH2 2 times COOH. Now first let me write down the general formula of your alpha amino acid. Now in the case of glutamic acid, instead of R, you have CH2, CH2, and then you have COOH. Okay. Now this is the case in which you have two COOH group, but you have got only one NH2. Therefore, this is acidic in character. Now in the case of neutral, you have a glycine in which number of NH2 and COOH is equal. So let me write down the formula of glycine. Glycine is where R is replaced by the hydrogen atom. So H, NH2, H, and then COOH. Now in this case, the number of COOH is 1, also the number of NH2 is 1. So it is equal, therefore it is neutral. Now in the case of basic amino acid, you have lysine as an example. Now in the case of lysine, R is equals to, you have CH2 4 times and then NH2. So let me write down the formula of lysine. CNH2, and then you have COOH, H, and then this group R. That is CH2 4 times and then you have NH2. Now in this case you can see that the number of NH2 group is 1, 2, but you have got only one COOH. Therefore it is said to be basic in character. Remember this example for each of this. For acetic you have glutamic acid, in which the R group is CH2 twice and then you have COOH. And in the case of neutral, you have glycine, or you can also give alanine as an example for this, in which instead of hydrogen, you have CH3 in alanine. And under basic, lysine is an example where you have R is equals to CH2 4 times NH2, and you have got 2 NH2 and 1 COOH. So this is based on the acidic and the basic character. The second classification of amino acids can be done into essential amino acid and non-essential amino acids. The essential amino acids are the ones which are not synthesized in our body. And the non-essential amino acids are the ones which are synthesized in our body. Essential are the ones which is not produced in our body, so you have to depend upon an outside source to get those. So those are essential amino acids. It is called as non-essential because it is already being produced in the body, so you don't have to depend upon an outside source to get those amino acids. So such amino acids are called as non-essential amino acid. Now, under essential amino acid, to give you an example, lysine is an example of the non-essential amino acids, whereas in the case of non-essential amino acids, you have glycine. Alanine is also an example of non-essential amino acid. Now the table in which the 20 amino acids names are given, in that the star marked amino acids are all essential amino acids, and whichever does not have the star mark are all non-essential amino acids. The essential lana contains lana lana kisi amino acids they ngado sobo nolo la setu we mena azo khala da shindo da karisa da dine ngazo rata chwa ba tinzo la kari lemna essential amino acids shilo ni rata che tinzo la essential amino acids che non-essential amino acids sadu sambala ngazo sobo nala thangbo ni seyu de sambala ani ngazo chilo ni lemo marba this ni kola kari la gore non-essential amino acid. So that's the difference between essential and non-essential amino acids. Now that we are done with the introduction and the classification of amino acid, now let's look at the properties of amino acids. The first property of amino acids is they are water soluble but insoluble in organic solvents. Organic or non-polar solvents. We know that water is a polar solvent. Now the solubility is because of the interaction with the water molecules. In the case of alpha amino acids, you have an acid group and you also have a base which is NH2 and then this H. Now because of the presence of the electronegative elements, there is a formation of intermolecular hydrogen bonding. Due to which it is soluble in water. Moreover, amino acids are polar in nature. Polar are soluble in polar solvents. Whereas the non-polar solvents like the organic solvents, because of its non-polar in nature, amino acids being polar in nature, it becomes insoluble in the organic or non-polar solvent. That is the first property of amino acid. The second property is they are colorless. They don't have any color. And the third property is they have high melting points. Due to formation of salt. In the case of amino acids, you have an acid group, you also have a base group. So whenever you have acid and base, it will react to form a salt. So because of its salt-like behavior, amino acids have high melting point. And the next property is they are crystalline in nature, or they are crystalline solids due to formation of zwitterine. Now for that, you first need to understand what is zwitterine. So let me explain the formation of zwitterine. In the case of amino acids, you know that it contains an acid group and then you have a NH2 and then one R and one hydrogen atom. The NH2 is the base, it acts as a base, and this acts as an acid. Now what happens is, when it is in the aqueous state, this O, being more electronegative, pulls the wanted electrons towards itself and it releases this H plus ions, whereas this nitrogen atom, which has a lone pair of electrons, it shows its basic character by accepting the H plus ions on it, which results in the formation of NH3 plus, and here you will have COO minus. RCH, C double bond O, O minus, and then this NH3 plus. Now this is called as zwitterion. A molecule which contains a negative ion which also contains a positive ion is called as zwitterion. But as a whole, it is neutral. As a whole, it is neutral. Neutral, but carries both positive and negative ion. And zwitterions are said to be amphoteric in nature. Amphoteric means which reacts with both acid and base. With both acid and base. So it is very important that you know what is zwitterion. It is a molecule which contains both positive and negative ion, but as a whole it is neutral because the amount of positive charge is equal to the amount of negative charge. As a whole it is neutral. Okay, now let me explain the amphoteric behavior of deuterion. The deuterion, that is CHR, and then you have C double bond O, O minus, and then you have NH3 plus. Now this deuterion, it reacts with acid, it also reacts with base. Now when it reacts with acid, H plus, what happens is this O negative will accept the H plus from the solution and it forms RCH, COOH, and then you will have NH3 plus. Now you can see that it contains a positive charge, therefore a cation is formed when it reacts with acid, but when you react it with the base, what happens is this OH minus will pick up H plus from the NH3 and it forms O minus, and then you have NH2. Now it is with the lone pair of electrons. Now you can see that this positive charge is neutralized by donating H plus to this OH minus, and you get a molecule which consists only of the negative charge. Therefore, an anion is formed. Anion is formed with a base, but a cation is formed with an acid. So this shows that the deuterion reacts both with acid and base, and therefore it is amphoteric in nature. Deuterion which is amphoteric in nature. So this is about the formation of deuterion and its amphoteric in nature. The deuterion nana khandicila la horila narva amino acid namola carbon dingala COH ke NH2 ke yorpa COH the acid re NH2 the karire base wa COH the acid in the samala ko acid ki kheje tengurwa acid ki kheje the khandis tongorla na kuranga na H yo di ma teni H plus tena acid lewa H plus the teni anin dela karire O minus the acid ki kheje teswa ta the NH2 yo di ya kora base ki kheje the tengurwa the kheje the khandis tengurna ko H plus the su lene ko khari chaire NH3 plus chaire ta dos chene khari ragre na ba molecule che na la negative charge ke yo positive charge ke yo dende chi yo wara china ko la khari le deuterion ine overall ta bi sambala ko neutral che khari chene na positive khazu yo adi negative digams ke yo sambala overall neutral che ine na la positive ta negative nija yo jimbara china dila deuterion le ta deuterion ki kheche chi khari le na ko amphoteric res amphoteric la di sambala acid ta base nija yendo react chine ta di khandes sugar la na deuterion the acid nyamdo react chudu sambala acid lana H plus kogorwa H plus the OH minus la attack chire plus minus nyamdo ligirwa kadina H plus the O gana leni ko negative the ma me wasure ani deuterion the khari lagurs NH3 plus yugyo bashi negative the me wachaswa khari form chasum cation chi form chire deuterion acid nyamdo la cation form chire like is it deuterion the base nyamdo treat chivarasna OH minus the giya khari chire H plus chilingi wa base the but in samala the NH3 ne S chilingi samala NH3 the NH2 la ranja chire NH2 che ani the COO minus the ranja devache those chine ta di na negative positive the mewa che negative chuko jibaswa ani anion chi form chire deuterion the base nyamdo react to this samala anion chi form chire deuterion the acid nyamdo form chire samala cation chi form chire those chine ko amphoteric behavior the tendency check. So with this we are done with the deuterion. Now let's move to the next property, that is the optical activity. The last property is the optical activity. Now any compound to show an optical activity, the condition is that it has to contain a chiral carbon atom. So the amino acids, except glycine, all other contains a chiral carbon atom. Therefore, all amino acids are optically active. Except glycine, which is optically inactive. Now for that, let me first write down the structure of glycine. Glycine is the amino acid in which you have H instead of R. R is equals to H in the case of glycine. And then you have COOH and NH2. Now you can see that a chiral carbon atom should have 4 different groups around it, but in this case, this carbon carries 2 hydrogen atoms. So because of this reason, this is not a chiral carbon, therefore optically inactive. All other amino acids carries chiral carbon atom, therefore they are optically active. Let me give you the example of alanine. In the case of alanine, you have R is equals to CH3, so CCH3, COOH, and then you have NH2, and then the R, okay, H. Now in this case, this carbon carries a CH3 group, a hydrogen atom, an NH2 and COOH. So therefore, this carbon is chiral as it is surrounded by 4 different groups. Therefore, it is optically active. And it applies to all other amino acids as well. So this is about the properties of amino acid.